Hi, hello, this is Jenny. So, today's lecture on compiler design. Okay, so this is a very famous and familiar topic in computer application. Otherwise, in information technology or engineering or computer science. Okay, so in all the departments, this compiler design is very main focus. Okay, so why we should study? Okay, so here you can see this construction or architecture, both are similar. Okay, so this is my sample code, and that code we are going to debug. Okay, so debug word by word, line by line, or what full whole program we can debug. Okay, so we are going to debug the error, or otherwise we are going to compile all the programs and we are going to get the original source code of that resolution, that is answer. Okay, so that's the reason we are going to study or can learn information about compiler construction or architecture. Okay, so next, what is compiler? Okay, so the compiler translates the source code. Okay, source code means which I given in that computer language. Okay, so that source code is going to convert into the machine code. Okay, machine code means target code. Okay, so for example, the user, I am thinking I'm going to create a some program for my organization. My organization is in construction. Okay, so just imagine I'm going to run a construction company, so I need some website or applications for the users. The users can see from their system what are the facilities they are providing and how many employees they are working, what are the projects they have done. So all these queries will be asked by the users. Okay, so each and every people can come and meet me directly to my office, or they can communicate through telephone. So it's not possible. I can't give answers to all over the world to all the people. Okay, so that's the reason I'm going to create some application. So that application should provide all the details to the users. So then only the users can access all the information all over the world. Then they can communicate to get my project, right? So that's the reason I'm going to create some application. So in that application, I should know how to create the modules. Okay, that means the design. For example, I'm the owner of that company. Okay, so Jenny's Construction. Okay, yeah, just imagine Jenny's Construction Private Limited. So I'm going to call the programmer. Okay, so who is making develop for my applications. Okay, so I'm going to tell this information to that developer. I need this module, so in front design you are putting my construction site photos, and then down you should give some links, for example, employees in office contact number and official projects, and then what other branches. Okay, so like that link I'm putting some designs. Okay, so designs to the developer, so the developer understands what I'm asking, so what is the queries of that owner. Then the developer is going to make according to my wish, right? So what are the designs which I have mentioned to the developer is going to make that design in that application. So that's the reason the compiler is very important. Okay, so compiler means they are the developer is going to create some other coding for that application. Okay, so they can use high level language or low level languages. Okay, so high level languages means we can get more secure. Low level languages means some of the systems they will configure and some of the systems they won't configure. Okay, so that's the reason my developer is going to write all the codings in high level language. Okay, so high level language means we need compiler. We should know about compiler and interpreter. So as the previous sessions already I said what is the difference between interpreter and compiler. Compiler means fully it whole programs it will check. Okay, so best example in real time I can tell when we go to shopping malls. Okay, so shopping malls, the metal detector, they have maintained some metal detector for the user scanning purpose. Okay, so when the user enter into their malls, the metal detector scan full body. Okay, when we go to airport, okay, for to get our airplane means the airplane airport center they will detect. Okay, they will scan all the um, human body as well as our packages. Okay, so that time also we are using that type of checking. So that is also one of the best example for the compiler. Okay, so they are applying this methodology for real time. So same methodology we are going to apply in our program. Okay, program means we are going to create some coding, so that coding is going to use in our applications. Then only we are doing some typing work for some business works on the systems, right? Okay. So next, the compiler. Okay, so machine code, it's in full and full binary form, the zeros and ones. Okay, and as a human being we don't know what is zero, what is one, but system, the electronic machine knows zeros and ones, that is binary form in technical word. Okay, and then virtual machine, for example, if I am using Java programming, I should use Java virtual machine for making Java code. Okay, another language such as C, C++, and then C Sharp, Ruby, Python, OCaml. Okay, lots of languages are available. Okay, so how in the real time or real world, how many people all over the world they are speaking lots of languages. Okay, Spanish, French, Tamil, English, Italy, Russia, Hindi. Okay, so like this in the computer also we are going to see lots of languages. Best example I can say, starting early languages is COBOL, Fortran, Python, Ruby, C, C Sharp, Java, okay, PHP, .NET, ASP, ASPX, okay, VB, like this languages we are going to make in this computer applications also. Okay, so now you definitely understand what I said. Okay, so and next, in this compiler or we are going to make some programming. That program we will use some expressions, operators, operands and expressions. Okay, so let's see one by one. What is the main understanding of this compiler? Why we should use in our coding? Coding means program. Okay, so why we should use this program? To make the applications for the users. Okay, for business. That's the reason we are using applications in the system. Okay, so compilers are complex programs. Yes, of course, right? Complex programs, not easy ones. Okay, so that time we have to write and run our program. Okay, so for that reason we should understand the compiler's work, how it's going to work. Okay. Next, for example, the compiler structure is we are going to give some characters in our program. Okay, so that character stream, what we call it as lexing, lex short lexing, and then the character stream is going to convert into a token stream. Okay, so best example in real time I can say I'm sick. I have some sick for my in my body. Okay, so I'm going to meet a doctor in the clinic. So that time I'm going to make a call to the clinic person, receptionist. What he or she will ask? Okay, they will ask our name and then they will give some token for our name or patient, right? So when I have the token, that time only I can go and meet the doctor. I can get the appointment at the clinic. Okay. The same methodology we are going to apply in our system. Okay. So first I'm going to make some program. I'm going to write the coding. So that coding is going to create a token. Okay. So, and then the token is going to convert the parse tree. Okay. That is synchronization, translation. That translation parse tree is going to create an intermediate code. Okay. So what the real time the doctor will say to the patient, if I get the appointment, now I go to meet the doctor. Okay. That is past. And then the doctor will call the nurse, that is intermediate. Okay, so here intermediate code. So the program is going, I written the program, so the program code is going to compile. So between the gap, it's going to call the intermediate language. That is which language I should convert. So the doctor will call the nurse, and the nurse, okay, will ask which type of company tablets or medicines can I give to the patient. Okay, lots of companies, they will provide the same medicines, right? So the nurses will ask this question to the doctor, which type of company medicines we can provide to the patient. The same methodology we are going to apply in our program. Okay, so in the intermediate code, it will ask the query to the users or developer, not users, developer who is going to make this application, writing the code. So which language is convenient to me? Okay, so that language here, for example, here I'm going to develop my language in Java. Okay, so that intermediate code asks queries to me, developer, as a developer. So I'm going to give my language is Java. Okay, so that is my target code. So now the program is ready in the Java code. It's going to compile. Okay, so now I'm going to check my program whether it is have debug, whether it has debug or not. That is compiler work. Okay, so multi-pass compiler does one simple thing. Okay, so passes the output to the next stage. Here you can see this example. Okay, we can use multi-pass compiler. So the main work of this compiler, here I'm going to use Java programming. That Java programming is my target code. Okay, so the intermediate code asks to the developer. So as a developer, I am going to make this program for Java, because all the apps, applications right now works on the smartphones. So in the smartphones, we are using Android applications. So Android applications means it's open source software. Open source software means all the people all over the world, they can use easy method. Okay, there is no need encryption or a decryption technology. So that's the reason the user friendly, user convenient mode, I'm going to create Android applications. So for Android applications, my language should be a C Sharp or Java. Okay, and then Python, PHP, it's totally okay different from this languages. So maximum Android applications, all the applications will be available on this Java platform. Okay, so that's the reason the intermediate code asking this question to the developer. So the developer target code is Java. Okay, so this is the work of compiler. Okay, so character, and then we can see the token form. Token form is going to semantics, that is parse tree, and then intermediator, it's going to translate the code to approximate or appropriate code, that is target code. My target code should be at Java. Okay, so that file mode is .obj. Okay, dot object code files we are going to create, that is OOPS concept. Okay, object oriented programming language, that is high level language I'm going to create. Okay. So when we are going to the high level language, it's going to convert to the machine language, that is what compiler. Okay, I'm going to translate. Okay, so this is the work of the compiler. And next, compiler programs we can use everywhere. Okay, so for example, query languages, serialization frameworks, build systems, game engine. Okay. Application game. Okay, we can create financial contracts for auditing section, and then tally. Okay, financial contracts we can make this program. And music systems. Okay, music composers then can use all the software, they have this type of compilers. Okay, so why we are using this compiler, how and where can we use this compiler? If you are asking this query to me, I will say this answer: compiler is everywhere, every software. Okay, so that's the reason I am telling this one by one. And text editor. Okay, so when we are translate languages from one language to another language, that time also we are going to use this type of software. Okay, and then hardware description languages. For example, we are booting some systems software, hardware system software. Okay, booting software. We have that compilers. And statistical computing environments. For example, meteorological center and satellite center. They have used this compiler. And browse engines. Right now we are using Google Chrome, Opera, and then Internet Explorer. Everything have compiler. And document processes. Okay, for example, PDF document, scanning document, everything. Okay, everywhere we can see this compiler. And continuous integration. Okay, and hub actions for blockchain platforms. Okay, and legal contracts, text processes, interactive system. Okay, testing systems. And then for a traffic control. Okay, everything, compilers, and Wikipedia. Okay, wikis. So lots of browse and search engines, all the games, all over the world, all over the software. Okay, we can see this compiler. And next, okay, is this compiler? If you are asking this question, compiler is to understand concept is very big or hard. Okay, so compilers is very easy thing, we can understand easily. Okay, not is a tough one. Compilers is not a tough to understand, it's a very easy to understand. Okay, so when we large program, for example, here you can see 2.1 million lines of code, development for 15 years. Okay, so here no, GNU Compiler Collection, GCC. Okay, so that type of compiler, it had been take over 15 years. Why? Because it is going to check 2.1 million lines code. It's going to check. So just imagine how the software should be. Okay, and then if we choose a simple language to compile, okay, for example, C, Java, or machine language. Okay, we can get small debug means errors, small type of errors, then only it can run easily. When we are writing long programs for over 15 years, 10 years, 5 years means it will take some time to compile all the programs. Okay, so the debugging is time will be late. Okay, compared with small programs. Okay, so C, Java, machine languages, these are the small programming languages. Okay, so we can compile easily. Okay, and then next, structure of a compiler, already I said. Okay, collecting, that is character, then parsing, and then third one is typing. Here you can make this tree format. Okay, for example, these are the parent A and they have two childs B and C, and then C have two kids. Okay, D and E. Like this graph we can maintain in this compiler. Okay, and next we are going to check front end and back end. Okay, so when we are going to build a house, in real time example, I can say I'm going to build a house. So what, how we can make this design? First, we can make that model in a front portion, and then back side also we are going to make that portion, right? So the same methodology we can applicable or apply in this program. Okay, so I have written some coding. I'm going to check front side as well as back side. Okay, so front end means in programming we are going to design, make the design, and back end means I'm going to store data. Backend I can use databases, front end I can use designs. Okay, that is a read mode only. Backend I can read and store. Okay, so here I'm going to check front end and backend, okay, for my program. That is also one of the compiler uses or structure. And next one is, this is the example for front end compiling. Okay, so here I have written some coding int x. Okay, so this is the what, expression x equal to y plus 1. Okay, expressions. So basic, when we are going to study computers means we can know about the operators, operand and expressions. Okay, so operators means this one is int, return. This is x star x is the expressions. Okay, operands means, for example, a plus, b plus. Okay, operators with operand. Operand means symbols. Okay, so this is called, what we can call it as in fundamental of computers, arithmetic operators or operators and symbols. In this topic we can see, or we could see that methodology. Okay, technique. And next one is the source code. So this is your source code which you can make as an operator. Okay, so here I am giving some arithmetic operators. That operators, that is my source code, is going to now translate, passes to this stage, lexing stage. Next stage is passing stage. Here also I am checking that debug. Debug means error, my program is whether my program is right or wrong, which I have written. Okay, and then next stage is type checking, and fourth one is AHT, that is graph methodology. Okay, so all checking happens, all error checking happens in which mode? Front mode only, not back end. Okay, so front side only I'm going to check all the errors. Okay, so that is front end compiler checking. Okay, here another example for your understanding. So here you can see I have written this code. This is my source code. Okay. So this source code, lexing. I'm going to do first compiler work is lexing. Lexing means the characters which I have written on the program. The characters is going to convert into a tokens. Okay. So how the program make this code? Left bracket, okay, left brace, and then let. Okay, so left brace means left bracket, this, and next one is let, id is x, and the number 1, then semicolon, id x, and then as x plus y. Okay, so id x and then id y. Next, semicolon, right brace, right bracket. Okay, so brace, right bracket, and then left bracket. So we can write this code. Okay, the computer can understand this type of tokens. So I'm writing this code, the system is automatically going to translate this mode. Which mode? Tokens mode. So the tokens modes, here you can see how the system converts. Okay, left bracket means we can write this code L brace. Okay, and then right bracket means right brace. then id slash x, next equal eq. So the computer understands this type of technique. And then, so next, the tokens, it's going to parse it, the third technique. So here the id, we can see that id and expressions. Okay, so I am giving that x equal to x plus y, right? So x is my id and x plus y is my expressions, right? And then next stage is definition. The computer asks this definition and I'm going to give some declaration. You should convert this number. For example, x value 10 and y value 5. So the answer should be, I should get 15. So the compiler should run this answer perfectly. Okay. So in between the code, if any mistakes happen, immediately the compiler produce that debug. That means in this line you have this error. Okay, it shows. For example, line 9 or line 8, you have this expected error or mismatched error. It shows. So that is the work of compiler. Okay. So next stage is definition, third stage is declaration, and fourth one is we are going to pass some command, and this is called block. Okay. So in this block we can see this type of parsing methodology in compiler. Okay. Synchronization. So here you can see the high level language converted into machine language. Machine language means low level languages. Okay. So the person who is speaking high vocabulary words, but the people, they don't know high vocabulary words, so they can translate their meaning as a simple words. So the same reason, the same technique in the computer. So when we are writing a high level language, the machine is going to compile in their own language, and it then after that it will produce a good that means not good, accurate result to the developers. Okay. And this is for the example for Java programming. Okay, so when we run in the Java compiler, Java virtual machine bytecode, okay, we should save .java format. Okay, so OOPS concept means we can create object and class. Okay, so that methodology here I applied. Okay, so how many lines here? Total 18 lines. Okay, so the compiler is going to check from 0 up to 18. So in between the line, if I have any error or any debug, it shows line 8 you have this loading error. Okay. So that time developer or the programmer should check that error and clear it. Okay. After that, if we run this program, we can get the result. So overviews in the compiler. So first one is stream, second one is tokens. Tokens means third stage is parsing. Parsing means syntax analysis. First one is um, what? Character analysis. Okay. Lexical analysis. Lexical analysis means stream of characters into stream of tokens. And second one is syntax analysis means the token into a parse tree, that is syntax tree format we can get. And third stage is compiler stage, translation, that is intermediation. Okay, so intermediate code. And fourth one is in which language you need, that is target code generation. So translates intermediate code into target machine code, that is high level language into machine language. Okay, machine language is nothing but assembly code. So another example for a compiler. Here we can see two types of operating systems. Okay, So first one is Linux operating system, another one is Windows operating system. Okay, so we can use open source software and closed source software. Open source software means, best example, Apple iPhone, that is closed source software. The third parties easily cannot access their information. Okay, so that's the reason Apple and iPhone, it's very costly. But compare with that other smartphones, Android, those who are making Android software, that is open source software, it's a very cheap and best, all over the people, all over the world, all the people they can use. Okay, so that is open source software. So compared with closed source software, open source software is we use is a very free use, uh, using techniques also, it's a very easy manner and cheap and best. Okay, so here we can see Linux operating system and Windows operating system. Okay, so Linux operating systems assembly language, assembler. Okay, so here we can use assembler to convert text from the text means character into binary instruction. Okay, so when I given text character, automatically it translates to the binary instructions. Okay, so here file format, how it will be means .s format or .o file format. Okay, that is .obj object file format. For example, for construction sites, their application, they can save their file .obj, that is a 3D model, 2D dimensional, okay, 5D dimensional, um, so drawing, maps, everything. Okay, construction means we should make that 3D dimension, 4D, 5D dimension for their construction design. Okay, so that design software, they will use this type of file format, that is .obj, object file format. They can use that assembler. Okay, that is Linux software, Linux operating system for their drawing or making design. When we use smartphones or systems, we can use Windows operating systems. Okay, so Windows operating systems, here we can use that compiler .exe file format. .exe means executable file format. Okay, executable means we can use, we can add what compile code, programming code, as well as libraries. Okay, for example, C program, we can create STD, standard input output H. Okay, that means libraries. Okay, so we can translate, we can add, okay, compile source code as well as libraries. Okay, so that is the use of Windows operating system compiler and Linux operating system compiler. Okay, so here file format for Windows operating system .exe, and then Linux operating system file format .obj. Okay, Mm. so C is the assembly code. So here you can see that how we can see this file format .c. Okay, so .c means that is the compiler is going to translate or compile your source code to the target code. Then it will produce us the error to the developer. Okay, so here you can get the result what? X. Okay, so star equal to X. If it is not X means you can get that OR value. OR value I given 1. Okay, so I given 1 for OR value. Okay, so if it executes X value means OR value does not apply. Okay, if it is run, if it runs the OR value means you can get the value 1. So that is my source code. So you can compile C compiler, C sharp compiler, Java compiler, Python, Ruby, PHP, OCaml, COBOL, Fortran. Okay, so every compiler you can run this source code, you can get that result. Okay, but the difference is the coding, that input output statement or character should be different, depend on the language. Okay, and file format also should be different. Okay, for example, I can, if I use C programming, I should use the dot C. Okay. If I use PHP means I should say the dot PHP. Okay. So all the programs when we are using this Windows operating system should be dot executable compiler format. Okay. So I hope you can understand everything. So next session we can meet or we can. Okay. So thank you so much for your attention.